and also table 4. So table 3 is actually how you want to find the probabilities, but again, it's depend on the shaded area. Okay, so what we give in table 3 is the value, your Z value from 0 up to 4.0. Okay, 4.0. The last value is 0. Okay, so other than that, so it's depend on the shaded area. Either you want to find Z greater than 4 or Z less than 4. So if you want to find Z greater than 4, the answer should be 0. But if you have Z less than 4, the answer should be equals to 1, because the total probability is equals to 1. So again, normal distribution is symmetry with respect to the mean. Okay, since we use a standardized normal, so standardized normal, you have your Z, okay, random variable Z is distributed as normal, mean 0, variance is equals to 1. So that's why in the middle value, the value of Z is equals to 0. Okay, so that's mean it is a symmetry bell-shaped curve, so it should be 0.5 and 0.5. Okay, you can have Z value, it can be either positive or negative. Okay, on the positive side or on the negative sides. Okay, so but again, since we read the table and it is symmetric, so that's why we only put this positive value. But again, you can find also for negative value. So because of the property of symmetric property for normal distribution. Okay, so table 4, you just want to find given the alpha, what is your Z alpha? So that means we give you the probability. You want to find the value for your Z alpha. So again, we will use both tables to solve for normal distribution. Okay. So the next topic for normal is approximation. Normal approximation. Okay, let us look at your module first. Okay, so this one is normal approximation. So again, we will use both normal approximation for binomial distribution, okay, and also normal approximation for Poisson distribution. Okay, so case when let's say if we start with a binomial distribution, so binomial distribution in your stats table, okay, in your stats table, you can have only from your p value, okay, you have your p, which is your probability or your pi. Okay, we start from 0.01 up to 0.5. Okay, and again, what happens when your pi is not in your table? So you have to change or modify from your x variable, we change to y variable. Okay, as long as your n is still provided in your stats table. That let's say if your x is defective, so you change to y for non-defective item. Okay, that is when you have your n still in table. That means your n is less than or equals to 30. Okay. For the case when you have your n is greater than 30, for example, your n is 35 or your n is 40, so that means we have to use approximation. Okay. For binomial, it can be changed to Poisson. Okay, binomial to Poisson. So if you have binomial to Poisson, okay. So binomial to Poisson, when we have the case, your NP is less than 5. So when you have your NP is less than 5, so normally we have your P, okay, your P or pi is small, for example, 0.1%, so you have 0.00 something, okay? So you want to check when your NP is less than 5, so your X from, so I just change that, I just use, instead of P, we just use pi, okay, and pi less than 5. So when you have this one, so your x is binomial and pi, so you will change to Poisson distribution with parameter lambda. So where your parameter lambda is equals to n pi. Okay, so again, properties for lambda, so mean and variance is the same thing. So that's mean once we change from binomial to Poisson, your mean is lambda, which is n pi. Your variance is also lambda, which is n pi. Okay, that is the properties for Poisson distribution. Mean and lambda, mean and variance is the same thing, which is your lambda. Okay. So when we have the case n is large, okay, again, but your n pi is greater than 5, greater than or equals to 5. So your x will be approximately become normal distribution. Okay, normal distribution. So when you have a normal distribution, you need your mu and also your sigma square. So mu in this case is your n pi, sigma square n pi 1 minus pi. Ataupun you can use NPQ. It's the same thing lah. So Q is 1 minus P. So again, we change to normal distribution with parameter mu and pi. Your sigma square is n pi 1 minus pi. Okay. From binomial to Poisson, it's just a discrete distribution. Discrete change to discrete. Okay, X change to X lah. X from a discrete distribution change to a discrete distribution where we have to use Poisson distribution. Okay. But again, if you want to change from binomial, when you check your n pi is greater than 5, greater than or equals to 5, okay, you want to change to normal distribution. So normal distribution is a continuous distribution. So when we have a continuous distribution, we need to do some continuity correction factor. Okay, continuity correction factor. So it's the same thing for Poisson distribution. Okay, tapi nanti Poisson nanti I will explain it later. Okay, we just proceed with binomial first. Okay, for normal approximation to binomial, so that's mean you want to change from a discrete distribution, discrete binomial, you want to change for continuous distribution, which is you have a normal distribution. So in that case, you will need a continuity correction factor. Okay, so a continuity correction factor ataupun in Malay we use this one as pembetulan keselanjaran. Okay, pembetulan keselanjaran. So a continuity correction factor is used when continuous probability distribution is utilized to approximate a discrete probability distribution. Okay, for example, you have normal distribution is continuous, the values can take real numbers. Okay, whereas the binomial distribution can only be integer or discrete value. Okay, kalau kita tengok normal distribution, it is a continuous. So continuous, it can take in terms of interval, in terms of decimal point, in terms of fraction. It can take any value, any real numbers. Okay, but binomial, only discrete values or integer, either 0, 1, 2, and 3, and so on. So that's why we need a correction factor. So correction factor is done by adding or subtracting 0.5. The value is 0.5 or half lah, yeah, from a discrete value of the random variable x, and thus filling the gaps to make it continuous. Okay, so that's mean kalau kita ada correction factor, if you want to change from normal to binomial, you have to add either add or subtract plus minus 0.5. Okay, daripada x tu, we need to add either plus or minus half. Okay, it's depend on the way either you have probability x greater than or probability x greater than or equal or probability x less than or x less than or equal. Okay. So again, this one, okay. So how you want to know whether you have to plus or minus half. Okay. So again, we have the list of formula here, but again, in here, this list of formula, if you look at this one, is not provided. That's mean you need to know how you want to change from a discrete to a continuous function by adding plus or minus half. Okay, so that is the way. Biasanya normally I didn't ask the student to memorize this formula because we have two many formulas in statistics. So normally we didn't memorize this formula, we just understand the concept. Okay, understand the concept. So again, so kalau let's say in the discrete distribution, each probability is represented by a rectangle. Ini, kita ada 0, 1, 1, 2, 2, 3, 4, and so on. Okay. So again, but when we have the continuous function, it should become a continuous smoothing curve. Okay. So yang tu yang kita ada plus minus 0.5 tu. Okay, kalau kamu tengok this one. Okay. So now how you want to solve this one? Apply continuity correction factor. Okay. Yeah. Just stop sharing this one first. Okay. Jap. Okay, so let's say if you refer to your module, so we want to do is the continuity correction factor. Okay, or you can write down simplify as okay, CCF, continuity correction factor. Okay, so you need to know that, okay, let's say if we have a binomial distribution, so X is binomial, you have your N, you have your pi. Okay, so let's say lah, if we have, I just give you your N is 35, your probability is maybe 0.6. So what you need to do, since you have your N is greater than 30, so you check your N pi. Okay, N pi, 35 times 0.6. Okay, what is the value? 35 times 0.6. So you have 35 times 0.6, you have 21. Okay, which is greater than 5. Okay, so when we have the case N pi is greater than 5, so normally we will have to change to normal distribution with parameter mu, parameter sigma square. Okay, so now properties for normal distribution, that your mu, since it's a binomial, so your mu is N pi, your sigma square is N pi 1 minus pi. So mu is equals to N pi. So in this case, mu is 21 N pi. So sigma square N pi 1 minus pi. So that's mean you have 35 times 0.6 times 0.4. Okay, what is the value? 21 times 0.4. So you have 8.4 here. Okay, sigma square. Okay. So that's mean your X now is a normal distribution. Okay, with parameter mu 21 and your sigma square is 8.4. Okay, so since X is binomial, you want to change to normal distribution. So we call that one is as normal approximation. Okay, case when you have your N pi is greater than 5. Okay, so now let's say, since in discrete distribution, equality sign is important. Okay, for example, let's say if you refer back to your table, you want to find probability X less than 3. So that does not include up to 3. So you just want to solve probability X less than or equals to 2. So the same thing, probability X greater than 3. So greater than 3 is just 4, 5 up to your N lah. Okay, so that's mean you have 1 minus probability X less than or equals to 3. So the equality sign is important for you. How you want to find your probability values. Okay, so again, let's say if you want to find exact value. So let's say lah, you want to find katakan X equals to 3. Okay, for example. probability x equals to 3. So for a discrete value, so the original question, this is your x. Okay, original question, this is your x. Okay, first your x here is your binomial. Ni x ni adalah daripada binomial. Sebab the starting question is, we give you a problem, is a binomial problem. Okay, but again, when you have your n is greater than 30, you have to change lah. Okay, you need to find something to approximate in order for you to find the probability values. Okay, your x is binomial. So in binomial, let's say probability x equals to 3. Normally, what we do is you change probability x less than equals to 3 minus probability x less than equals to 2. This is what we did. If you want to refer to binomial probabilities, because what we give to you is cumulative binomial. Okay, but again, if you want to change this one to a continuous function, which is normal, okay, in normal distribution, we don't have exact value. Okay, that's mean you haven't solved, okay, probability z equals to 3. Ada tak? Pernah tak selesaikan probability z equals to 3? Normally you solve is z less than, z greater than, or z less than or equal. Okay? You haven't solved z equals to 3 because in continuous function, we don't have exact value. If we have exact value, the probability is 0. Okay, sebab dia continuous, dia tak boleh ambil nilai yang betul-betul tepat. Okay, it must be in terms of interval. Okay, when we have this kind of case, okay, normally, when we have a discrete, you want to change to normal distribution, you have to add plus minus 0.5. So that's mean you will have 3 minus 0.5 less than x, 3 plus 0.5. So that's mean if I write, okay, probability x equals to 3, okay, nak letak CC pun boleh ataupun CCF pun boleh. Okay, continuity correction factor, you change to 2.5 less than x less than 3.5. Okay, because the reason we cannot take exact value. Okay, di sini, this one, discrete. Ini discrete. Okay, you want to change now. This one, continuous. Okay, once you already arrive at here, between 2.5 and 3.5, then you need to standardize, change to Z and read from your stats table. Okay, ini first step dia. Okay, first step here is this one lah. You need to change to interval. Exactly 3, so change plus minus 0.5. So lower limit minus 0.5, upper limit plus 0.5. Okay, that is the first one. Itu yang paling mudah untuk dihafal lah. X equals to 3. So minus 0.5 plus 0.5. Okay, let's say you want to find, okay, we just follow the module. Okay, so let's say probability 3 less than x, okay, less than 5, katakanlah, ya. 3 less than x less than 5. Okay. Ataupun, okay, sebelum this one lah. Okay, saya just tunjuk ni dulu. Okay, you want to find probability x less than 3. Okay, you want to do the continuity correction factor. Okay, so it's the same thing. You imagine that you have a rectangle here. So 3 is in the middle value. Okay, so 3 is between 3.5 and also 2.5. Okay, because we have a discrete and discrete in terms of rectangle, and then if you have a continuous, it's just a smoothing function. Okay, 3 is between 2.5 and 3.5. So you want to have x less than 3. So x less than 3 is not included in the bar. Okay, it's not included in the bar. So we just correct it to probability x less than or equals to 2.5. Okay, x less than 3, kamu bayangkan you have a rectangle between 2.5 and 3.5. So less than 3, you don't have equality sign. So just up here. So x less than or equals to 2.5. So let's say now you want to find x less than or equals to 3. Okay, less than or equals to 3. Okay, so x less than equals to 3, so over here. So you correct to probability. Again, this one, you have x less than 3.5. Okay, okay, one more thing. The equality sign, okay, from the first start here, this one is important. Whether you want to determine whether you have to plus 0.5 or minus 0.5. Okay, first step ya. First step, discrete punya soalan. Okay, discrete distribution is important for you to determine whether that one have equality signs or not. But once you have already changed to continuity correction factor, let's say in here, okay, we use different color. Okay, here, okay. It doesn't not really important either you put equality signs or not, because once we have this one, you will standardize Z, okay, 3.5 minus mu divided by sigma. It's already become a continuous, so continuous have equality signs, doesn't have equality signs, is the same thing. You still read the same value in your stats table. So maksudnya kat sini, kalau let's say if you didn't put the equality signs here or without the equality signs after you already done continuity correction factor, I didn't penalize you. Okay, because it's the same thing, because you want to read from your stats table, it's already continuous. Not really important about the equality signs. Okay, but for discrete, yes. Discrete, yes. First part tu, kita nak tengok. So let's say x less than 3, you tukar x less than equals to 3.5. Kat sini dah salah lah. Okay, you hilang markah lah kat sini. The way you want to correct doing your continuity correction factor. Okay, normally 2 markah akan hilang. Okay, 1, your continuity correction factor, and then the last answer. Method standardized, betul. Maksud saya minus mu divided by sigma, betul. Kita tak minus that one. Okay, but the answer is wrong lah. Okay, because you will read different value from your stats table. Okay, so again, x less than 3. So less than 3, you imagine your rectangle is between 2.5 and 3.5. So less than 3, just here. Does not include in your bar, so 2.5. Less than or equals to 3, so ambil daripada atas ke bawah. So you have 3.5. Once dah expert, tak perlu lagi sketch your rectangular ni, tak perlu lagi rectangle ni. Okay, tak perlu sketch lagi. Once kamu dah faham, terus je lah do your continuity correction factor. Okay, let's say if we have probability x greater than 3. Okay, x greater than 3. You want to do your continuity correction factor. So greater than 3. So here. So you will correct to x, okay, greater than 3. So that's mean you will have this one lah. Okay, 3.5. Nak letak equality, tak nak letak, tu is up to you. Okay, so if you have probability x greater than or equals to 3. Greater than or equals to 3. So daripada bawah ke atas. Greater than or equals to 3. So you will have probability x greater than 2.5. Okay, so greater than 3 sini je. So 3.5. Greater than or equals to 3 daripada bawah sampai ke atas. So you betulkan, so up to 2.5. Okay, boleh faham tak dia punya konsep rectangle ni? Okay, sebab kalau tidak kamu kena hafal formula lah. Hafal formula. But it's the same thing lah. Tapi again lah, yours is open book. Even though kita tak state is open book test, tetapi still you can refer to your notes. So boleh jugalah tengok pada kamu punya nota. But again lah, after we have face-to-face punya ni, or if you join your degree program later on, you need to understand. Kita tak bagi dah dia punya formula yang dalam kamu punya buku asasi ni. Okay? So because in degree program, normal approximation is important, but again, degree program, you don't have your x. Okay, x ni dia punya random variable. Okay, tapi kita deal dengan sampling distribution. Sampling distribution, that's mean you have your ni, proportion P ni. P is just x over n. So this is your sampling distribution. Sampling distribution for mean and so on tu. So sampling distribution for proportion. So again, we have to use plus minus continuity correction factor juga. Okay, sebab the original question is your X is binomial. So you want to change to normal. But in terms of proportion. Okay, proportion maksudnya P kamu 0.2, 0.3. Kalau yang ni X kamu 3, 4, 5, 10. Itu dia punya integer lah, dia punya value. Tapi ini proportion. Okay, pecahan lah fraction. 0.2 and 0.3. So again, that one is on the sampling distribution. Okay, later on. Tapi konsep what you already learned in normal approximation here, plus minus half ni, nanti dalam when you go for statistic, engineering statistic, plus minus 1 over 2n. Dia ada n divided by your sample size. Okay, dia lain sikit lah. Tapi again, kalau kamu dah faham konsep kat sini, during your foundation, it's much more easier lah when you go to your degree program. Okay. So that's mean kalau let's say, bagi saya lah, kalau foundation UTM for statistic, you learn more than your friends in other foundation program. Okay, based on, kalau macam asasi UiTM pun, sebab asasi UiTM, combine mathematics and statistic in one syllabus. Cuma dia ada math 1, math 2 kot kalau tak salah saya dalam 2 semester tu. Okay, but again you all very specific, very focused, which is you have your calculus kan. Calculus, apa lagi? Basic maths tu, panggil apa saya tak tahu lah dalam foundation. But for ni we have the math method 1, math method 2. And then for engineering pun you have engineering math 1, engineering math 2 if you're further for your degree. And then next nanti kamu akan ada DE juga DE which is differential equation for engineering student and also numerical. Dia kalau nak engineering for nak masuk faculty of engineering, you tak boleh lari daripada subjek matematik lah. To be a good engineer, you also need to be a good in your mathematics punya syllabus lah. Okay, so that one is your continuity correction factor for this one. Okay, so katakan let's say, okay, so let's say we have between okay, let's say you have probability okay, 4 less than x less than 6 katakanlah. Okay, so again 4 less than x less than 6 ni you have to look one by one. Okay, check one by one for continuity correction factor. So between 4 and 6 you just consider x greater than 4. Kita tengok ini dulu. Kalau x greater than 4, okay, 4 kamu kat sini, ini 4.5, this one is 3.5. So greater than 4, sini je. So you correct 4.5. Okay, less than x. Okay, x less than 6. So less than 6, katakan same lah. Kamu ada bar juga. Okay, 6, 6.5, and then you have apa? 5.5 So x less than 6, so tak termasuk dalam bar ni. So sini je. So you correct to, you correct to 5.5. So that is your continuity correction factor. Okay. So tengok one by one. Okay. For between ni, kalau between, it must have one side is minus 0.5, the other side should be plus 0.5. Okay, dia tak boleh dua-dua minus 0.5 ataupun dua-dua plus 0.5. Dia salah satu je, satu plus 0.5, satu lagi minus 0.5. So it depends lah. Okay, kalau let's say if you have 4 less than equals to x, less than equals to 6. Okay. So again, you want to do your continuity correction factor. Okay, this one x greater than or equals to 4. So greater than or equals to 4. So daripada bawah sampai ke atas. So you akan betulkan 3.5. Okay, ini nak letak equality, tak nak letak, so it's up to you ini. So x less than equals to 6. So less than or equals to 6. Daripada atas ke bawah lah, less than equals to 6. So you have 6.5. Okay, so just check whether you have equality signs ataupun tak ada. Itu je. Okay, tengok dia. Tapi once dekat sini, nak letak equality ke tak nak letak tak depends. Okay, bergantunglah. Okay, sebab kita nak standardize je. Kita nak baca taburan normal dah. Okay, tak ada apa-apa efek lah. Yang first part tu saja. Okay, so that is your continuity correction factor.